Okay, so I will say welcome again to another session of our Ernie Academy. My name is Alejandro Diaz, like I said, and I am a backend developer for Ernie. A little bit about my background. I'm a backend developer right now, and I have more than 10 years of experience with .NET and Microsoft related technologies, developing cloud solutions for different clients. And right now, I'm involved in the development of cloud solutions for one of our clients related in the area of the medical devices. So today we are going to have a session about Azure IoT Hub, that is a solution for IoT from Microsoft Azure. So let's go to the presentation today. So uh, what we're going to see today is just to keep online that what we're going to do today. I just have a couple of slides. There is going to be mainly code, what we're going to see today. So, but first we're going to define some basic concepts related to what is the Azure IoT Hub. We later going to create together an Azure IoT Hub. We're going to create a device in this hub, and we today we don't have any real device, so we're going to simulate a device using code, and we will send messages to the cloud, and we as well we will create another application to listen to this device and to communicate with this device using the IoT Hub. And in the end, we will see a little bit of what is Device Twin. Is a feature of Azure IoT Hub that we will see a little bit in the end of the presentation today. So let's go ahead and Azure IoT Hub. If you're familiar with the cloud has different kind of services. Uh, and Azure IoT Hub is one of these services of Azure that is a platform as a service. And what it gives you is just a way to handle communication between devices and any kind of API or backend code that you have. You have a centralized hub for connecting every kind of devices to this hub, and then you can do different kind of things like we see here. We can do different insight, data analytics, business intelligence, artificial intelligence, open the data. We can do monitoring. We can control these devices from the backend as well. And what kind of device? Everything can be connected. Everything that have a connection to the internet, basically, you can connect it to the IoT with the proper connection string that we're going to see today. So let's go directly to a demo. So if you're not familiar with, wait, is yes here. Okay, if you're not familiar with Azure, Azure is the cloud solution for Microsoft, and you usually you need to have a subscription to in order to try Azure, but you can start for free if you want to. Right now, you're going to start trying the code that we will see today. You can right away create an account, and if it's the first time that you create an account, you get a free subscription that give you for a year a lot of free services and plus $200 in credits that you can spend in different kinds of services. But we're going to use one of them today. So let's go to the portal. Okay, let's go to the portal. This usually is the main view of the Azure portal, and in here, if you want to create a new IoT hub, you're just going to create resource and go to Azure IoT Hub. just IoT Hub, IoT Hub, just like that, and just click create, and we'll need to see different kind of um, things that we need to define here. The first is, like I said before, in Azure, you will need a subscription in order to create anything in Azure, and this subscription is bind to your payment method, but you can start for free if you want. Even with the subscription, there is a lot of Microsoft Azure resources that has uh, a free tier, and you can try it out. For example, IoT Hub is one of them. So resources in Azure are grouped in resource group, and let's just search this one. And you need a name for this. This is going to be the name that will appear in the URL. Will identify your hub. This needs to be unique, and take into account that this is publicly available. You can obtain somehow, people can obtain somehow these identifiers, so you can put different identification. But for testing purposes, just to create a IoT Hub Ernie, for example, is available, and then just pick a region that is close to you. In this case, West Europe. Let's go to networking. Let's not worry about this right now. This is just allow public access because for the demo, and we get to the local the place that we need to say, okay, what we want, what are the capabilities that we want in this. The standard tier is the default that it appears, but you have different kind of tier. You have a free tier, basic, and standard. Usually the difference is the capabilities that you have, and the basic difference between basic and standard is that standard allow you two-way communication, and basic, you can choose a basic one if you only want to send, for example, telemetry from the devices to the cloud. And the standard tier is, for example, the capabilities is two-way messages, and you can send up to 400,000 message per day per instance of IoT Hub. You can see here that you have, for example, one instance, but you can scale this on demand up to, for example, 200 instance. And the cost of one instance in more or less is $25 US. Usually, when you go to Azure, all the prices are in US dollars. But let's choose the free tier, because if you want to learn more about IoT Hub, you can just search the free tier. He's just giving me this error here right now because I already created one previously, because the creation of this IoT Hub could take a little bit of time. But let's just see what offer the free tier. You can send two-ways communication as well. You have message routing, that is this thing that we're going to see, cloud to device command, we are going to see that as well. And you don't pay anything, and you have a 8,000 message per day, basically. So what you usually will do, let's just standard tier. Tag is just, never mind about, don't worry about that. And then you just hit create, and Azure will launch a deploy of IoT Hub instance for you. Like I say, I already did that. So after the process of clicking in create, what did happen is you get this. This is the IoT Hub resource in Azure, and this is the main interface that you have. You have different things here. You have basic information, access to scalability. If you want to scale, you always can scale your hub. You can go to a standard, go to basic. Uh, and what is important, I want to go to the device section. In the device section, you will have all the device in your IoT hub. There's advanced ways to do this, but the basic workflow is that you will need to create a device in the IoT hub, and then your physical device or your phone or any device that you want to create, that you want to communicate with the cloud, you will give this device the connection string that we're going to see, and then uh, with the NuGet packages or the different libraries that are in different languages, not only in C#. The code that we are going to see today is in .NET, but there is libraries for IoT Hub for C, C++, Java, JavaScript, and Python. Yes. So the first things that you will need to do, for example, if I want to just create a device to our little demo, is just add a device. You will need to put a unique ID here, and there is different type of authentication for this device that you're creating. Right now, we are going to use the more simpler one, the symmetric key, and he will automatically handle this. But you also can have provisioning services that assign certificates, self-sign of signed by the certification authority in order to give more security to your service to your device. I already create one, and this is yes, I don't want to. This is this simulated device that when you click create, let's just create one, for example, device 2, for example. Oops, something happened. Yeah, okay, we're back. Device 2, and let's just click create, save. He will just provision this another device, and just can delete it. From the cloud, you can just disable this device, and this device cannot communicate with us, because what we're going to do right now is what we will need from this device in our code. Well, we will need the communication, the primary connection string, the secondary. And if you see from here, I can disable if I don't want to a specific device communicating more with the cloud. I can disable all of these operations that you see here. You can do it by code. You can automatically disable different kind of devices based on a certain query that you do, and so on. And what we're going to see today is a message from the device, a direct method from the device, and a little bit of the device twins. So I already copy this user string, but usually what this user string look like is just host name, and in the case that this specific device ID has in his managed key, like we created, if you go back, we created this device with SAS authentication. He will contain as well a signed signature from the IoT device. So let's go. We are going to use Visual Code here, and what we will need to our code is, like I mentioned, we will need to get the device ID, the device primary connection string, and another two strings. What are these two strings? If you see here, there's another section for the IoT Hub, and there is a lot more here, but we are not covering this today. We are just going to with a simple beginner approach. So the first thing is the following: the hub has already built in different kind of services in order to distribute telemetry or messages. And one of these services is the IoT uh, built-in event hub. We will connect to this event hub in our code, and we will listen to everything that is sent by the devices that are connected to the IoT and are sending device. And the other things is that we need access to the IoT hub from our code in order to send commands to the IoT hub. And for that, we go to the security settings here, and there is a lot of different kind of shared access policy. You can create custom one, but usually if you're going to only access to the device from the device, you could use the device connect, or you could use the service. For now, we're going to use the IoT Hub ownership that contain everything. You can do everything basically. So I already copied this in our in my finished solution. I will just not show it here for you, but basically what this look like is something like this: hostname, the hostname, and the shared access key with the signature behind. So with these three, let me open. With these three device, our device is called simulated device. So let's start to creating our code. Okay, first let's go to create a device. How are we going to create this device? We are using .NET. If .NET 5, that is the we are using right now. Let's go to cd code. Okay, let me just pull a little bit this. Let's create a file here. Simulated device. Good. Okay, and here just going to create a console application, a simple one. Good. So if we go to here, we have just our hello world program, and we need to, for this is going to be our simulated device. For just we could substitute it with a real device, or we can with a plug and play device that the Azure offer as well, an application that simulate of this, and you can connect to you can use your phone for sending telemetry like accelerometer and all of your devices. You can simulate this and send it to Azure IoT Hub. Basically, you can send anything that you want. We will need these three packages. So let's install these three packages in our solution. Okay, first one. This is for our created a client. Okay. And .NET JSON, because all the communication between these use JSON. Okay, cool. So now let's just copy for our code constants. Now here, I don't want to copy. I just want to. Oh. Okay, good. So we have in here our connection string. Don't worry about if you. Sorry, my mic just went off. Don't worry about if you see the connection string or not. There is no problem, because after the session, these resources are going to be removed. So right now we have just a simple program, and I have some code already implemented here, because if not, we're going to just be typing here. Okay, so let's simulating device. So the first that we are going to do is let's what we're going to simulate is just a device that checks for the temperature and humidity. We're going to simulate that and send that data to the cloud. Let's just use some code that I already have prepared here. So, okay, and let's create our device. We will need a connection string. Okay, woof, a lot of code. So what we have, oops, just a minute. Oh, sorry, I copied the wrong thing. So go back, nice effect. Yes, now we have the correct code. Yes, yes, it's compiling. Okay, I'm going to just copy the code that I already prepared and I'm going to explain a little bit about it. Let's just remove this one and okay, more code here. Don't worry, I'm going to explain everything right now that we have here. And we as well need this method here. This is not the perfect code, it's just demo code, but it's sufficient to you get to understand the concept, the basic concept of IoT Hub and what we can do with it. And then, yeah, in the end, I will give you direction to where to go in order to get a little bit more of knowledge about this. So let's see if it's compiled. .NET build. Good. So what we have here is this is just prettier printing, and this is our device. Our device is just a device that we're going to simulate that create just check the temperature and the humidity and have a fan, and you can we will then start or stop this fan from the backend of for using the IoT Hub. This, for that, for the communication with the IoT Hub, we will need this device client class that is from the Microsoft Azure device client. That is one of the package that we use, that we install. So it's already prepared for you. What you need to do is just to, okay, let's create a client using the connection string that we copy from the IoT Hub, and we can establish the type of transport. By default, IoT Hub allows MQTT. Is if you're familiar with that, is just a protocol for communication focused on IoT from IoT devices, but uh, this is not a requirement. You don't need this package for communication. You can communicate directly using the protocol MQTT if you have the connection string. And you also could use HTTP 101 or EMQP. You also can as well use that protocol. By default, he select the MQTT, but you can use, or there's two. It would depend of the necessity of your solution. So we create this. We will create this. We create this client, and now that we have a client, we can use that client to send message to the cloud. And what this send device to cloud message do? Well, this is just random generation of let's generate temperature and humidity and just send a fan. The important is this part here, that we create a payload of what we want, and then we create a message. This is a class from this IoT Hub, but like I said, this is in the end is just a payload of JSON that you're going to send in your request, and we will send different kind of messages. In this case, just if our fictional device has a fan, if it has a failure, we can send true or false. We can indicate that, and as well because we have defined that our desired humidity and temperature has some limits, our device could send as well, together with the current telemetry, we could send as well different kind of messages. Okay, if the temperature is outside our limits, just send a message, and then in a backend application we could decide if we receive this alert from the device of this data from the device, what can we do from there. We can and we will see it. We can maybe trigger some kind of operation or send an alert of just communicate it with another IoT device of with this one and say, okay, do this in this case. And it's very simple to send message. It's just to create a client, create a message. Message is just like you see a payload of JSON and some properties that are just key value pairs, and just use this client to send the message, and that's it. And we have just a delay here for sending. So let's try it out. I hope this works. .NET. Wrong. Yes, we are sending data to the cloud. So now, how we can read this data? Well, we will first let's go and implement another a backend application. Let's call it like that, but it's going to be just another console. Just kill this. In order to create a processor for this that is going to read from the IoT Hub, actually it's going to read from the event hub that I mentioned. If you remember, I mentioned that the IoT Hub has already built in different kind of endpoints, and one of these endpoints is a event hub. It's just you can see it like a queue of messages, but it's optimized for a lot of millions of messages, and is very used in the IoT environment. So the actual messages that we are sending are hitting this IoT hub, and we're going to read it. Let me see if I can in the overview. Yeah, if you see here, you see that already the integrated telemetry that that is in the IoT hubs, it is saying us that you have one device uh, and you have different kind of, you send a lot of messages here, and we will let's just do the code to implement these there's another different this backend. This let's just open a different terminal here. Again, go to codes, and then here let's make a different one and call it simulated device operator. Sorry, I'm bad with naming things. So let's go again. Okay, and here we're going to do just another console application. This thing could be anything. You could have a web API that read from this. If you're familiar with Azure, you could have here a function that read from or data analytics system that just get all this data and storage for later processing in a business kind of artificial intelligence environment, or just for logging this information, or you can have a different kind of web service that process this data and make a different kind of decision. Okay, where are we going? Okay, let's get .NET. Oops. .NET New Console. Yes. And for this one, we will use just let me just open it here. Okay, cool. For this one, we will use different. Let's close this. We will need the event hub. That is, this package is for that you will use to connect to any event hub of Azure. Doesn't not specifically with the IoT Hub. You just read from the IoT Hub itself, but the IoT Hub service has a built-in event hub. So let's just add this packet. Nice. We are using the same package of device just to create these devices. Okay, cool. And just again, just newtons of JSON to cool. Okay, so again, I have some code already prepared for you. So let's copy this code and let's discuss it. All right. We will need what we will need for the device. We need a device client, and now because we are using an IoT Hub, we'll use an IoT Hub client, and as well we will implement. Let's just format a little bit. Hit this one. We will implement a receiver for this message, and let's just copy paste some pretty printing here down here. Never mind this. Yes. Okay. Let's just our main. Let's connect to our hub, and let's read for our hub. Cool. Let's see if this works. Is .NET. Something is missing here. Oh, sure. The same way, I have different kind of constants here for my simulated. Let's try again. Cool. Don't worry about this warning here. It's just because it has to be with using this getawaiter. It's like you could just await. If you're familiar with C#, just await get result. But we will just keep it like this just for this demo. Okay, so what we are doing here, first of all, we are connected to a hub, to an event hub, and for that we need an instance of this, and we create using our package that we installed we create from the connection string that we get from here in built-in endpoint. It would depend of what kind of policy we select if we want to service of IoT Hub. Usually you use just with service because that is the connection string that will have a different kind of backend service, and depending of the responsibilities of that system, maybe this system do not need access to everything. But for the test for this demo purposes, we're just going to use the all access. um, and that's it. Later, with this event hub, we just get the runtime. And in this event hub, it's just I'm not going to enter in very detail here, but it's just the way that event hub communication works. You have different partitions for dividing all this information that you get to the event hub. But this is out of the scope of the IoT hub itself. It's just how the event hub works. Right? It's just imagine if you are not familiar with this, it just imagine that it's just a queue that you are receiving message from him. It's just a delivery service for receiving messages. So what these receive messages from device do is very simple. Create a receiver from that client with different kind of options here. Don't worry about that. And just there are different strategies to pull in these kind of events. For example, if you are familiar with Azure functions, you can have a trigger that every function is triggered for every events or amount of the events, or you can connect it to a logic app, is another service from Azure, and do different kind of things. But here we're just receiving the event, getting the body of this is a JSON that we sent, and just spit it out in our console here. So let's clear here this a little bit. Clear here. Let's test it out. Let's see if it works. So let's run our device. So our device is sending data. Go ahead. Okay, and let's hope that this works. So yes, we are receiving data. All this is sent into the Azure IoT Hub, all this telemetry. The Azure IoT Hub is publishing this telemetry in the Event Hub that he has integrated. And in our service here, that could be in another place, in another service, in another region of the world, we are receiving that information from this device, and we are receiving exactly the same that we send that we receive from the same message that we send. Here we receive more, but if you remember in the simulated device, we put in the message, we put the payload that we are printing here. This is the temperature simulated and humidity, but we also printed these two things. We printed the humidity alert and the if this happened. And in here, we just getting all the properties that the value is true, but we could actually get to headsets time to time just go off. So all the things that are true we're just printing here, and this is just the two alerts that you see here. Everything that has true we are printing. If for some reason our simulation get to a failed state in the fan, well, we will get this as well here. We we could we get everything that we put, the body and all the properties related to this event. So until now, what we achieved, we created a device that we connected this device to the Azure IoT Hub. We send data for that device, and we can read this data, and then we can do anything with the data that you want. It would depend of what is your business, what is your solution that you can have. You can, for example, you can monitor your, if you have the different kind of devices, you can monitor you can do for free in Azure. You could have a monitor system for your house. You got devices, for example, that monitors things in your house, and you could, using more or less the same code, you could connect this device on your house to the Azure IoT Hub, and then you can do an application that sends you a message every time that this device in your home detects something and makes you a message. But it's the same concept here. So let's go ahead and do something about this temperature alert. Now that we are receiving this telemetry, we can do another thing. We can interact with another concept that Azure IoT Hub, that is message from the cloud to the devices. If you remember here in our, let's go to the device here. We use this message to device, and we're going to use the what they call the direct method. The direct method is just a way that a service can communicate with a specific device. This doesn't mean that you can control directly the device. Of course, as if you can set a message. If the device has the capabilities for understand this message and do something, well, you actually can control it. But all of that is on your control. So let's do that. Let's just we need to create two things to direct method. We need to create in our backend application, or this our console here. We need to create the way of communicating with the Azure IoT Hub and send a message that we want to, for a specific device, we want to execute the methods, and we want to with a payload. And then in our simulated device, we also need to register a callback for getting when we receive a specific message from the IoT Hub, react to that and do something. So let's do first the simulated device, our backend. So let's go for that. We will need communication with our IoT Hub. So we will need a service client for that. So let's copy here. We need the service client, and this service client identify just a connection to the IoT Hub. And then what we need to do is we will create. Let's just close a little bit here. Let's create a service client. If you don't remember, when I get this connection string, just go to the portal. Let me go back. And in chat access policies, I would get a connection string for the service. We use right now the IoT Hub owner just because I have all the right, but you can use just this one that just have service kind of connection. So you cannot register a new device using APIs, or you cannot delete devices. You only can send a message to devices and so on. So the other thing that we need is a way to invoke some code in our device or devices using our. So for that, let's go to this one. Okay, let's hurry up. That it's a little bit late. So basically, what we do is just create a cloud to device method. Let's call it set fan state. We receiving this alert, and we need to send the information to the device. Okay, you need to turn on your fan because this is run. So what we do here is just create a method with the information. This is what we want to call in our device, and this is the time that I will wait for to respond. This is the payload that I want to pass to that methods in the device, and just using the service client that we already created. Just okay, for this device, this is the device ID. Just do this method invocation. Now if we just run like this, nothing is going to happen because our device don't have the logic to respond to that. So for that, what we're going to do, just close this. Uh, okay, and close this as well. What we need in that is uh, we need to create first a code to respond to this uh, to this call from the cloud, and then we need to register that. So let's do a simulation here. Okay, let's put it down here. And the other thing that we need to do is just to register. So, two steps here. The first one is to tell the device client, okay, oh no, sorry, this is the wrong one. I go too far ahead. I put something for the device twin that we're going to see later. Yes, we are only telling the client IoT Hub. When the IoT Hub send me a invoke method with the name sendFanState, just call this callback here. And this callback is just any kind of the logic here is your logic. You receive a method request that has all the data that the cloud send you, and you give a response because you actually from the backend you can know if your method invocation was successful or not. You can say you can receive a response from the device as well. So it's just like a remote processing calling. So this is just standard code for reading. Okay, give me the data. This is JSON, and just try to set the fan state, and you will see here a message that the fan is going to set to an state, and then we'll just give a result with the response of the 200 that everything will weld, and the result is just a method that we're going to receive that response in the backend. And if some problem, we just return 400. So let's see if it's running. .NET. Oh. Okay, it's sending. Okay, let's now start. No, .NET. Mm-hmm. What is not working? Let me see. Ah, of course that is not working. I forgot to save the file. Now let's try again. Mm-hmm. Hmm. Let me just see here. Of course, I am not calling this because yes, I forgot to call it. We will need to actually send the method. So let's just the first things to do. This, of course, that will need different kind of logic. We will need to send this in reaction to a message, but for simplicity, we're just going to uh, the first thing that we're going to do is just invoke this method, and this will just send a message. So let's try again. Come on. Hmm. Let's see my code here. Hmm. Let's just explore. If it's not working, just trust me, it work. But this is a demo effect. So let's just try a little another again, and let's just oops. Let's see. Let's kill this one. And for here, if not working, just demo effect. Don't worry. We need to leave with that, and let's go past to the next topic. But it should work. Yes. Okay. Let's try again. So, work. Yes, perfect. So you see here that I was putting message and this the backend connected detect something. Well, the first thing that do is just okay invoke this method set fan state, and you can see here that we just print fan set to on. So now we just kind of what we do is we could implement with this a response to this alert and send a message back to the device and see if we obtain an answer of not of the device. So we are almost finishing the time, but let's just recap here. We created an IoT hub, we created a device, or we connected a device to this IoT hub. We send messages using the IoT hub. We read these messages from another application, and we react to these messages and send back a call for the device in order to the device to do something. Uh, this is a way to do this, but there is another way that is more complex and you can do more things with that, and that is with the device twin. So what is a device twin? The device twin is a thing that is just a JSON document that the IoT Hub maintain for every device. So every device that you create has a device twin. And these device twins are just a JSON that is composed with three things, basically thing. Task that is just for the backend. You can tag different kind of devices, and for example, all the devices in a region or the device with certain characteristic, and you can query these devices from the IoT Hub. You can do different kind of operation with that. Uh, Other services can tag as well these devices, and you can react to these changes. And then are the properties. The other thing that you can see here is just the last connection update and the type of authentication that you have. The most important thing is the properties. The properties are that you have desire and reported. What do this mean? Desire is what the backend application or your configuration wants to set or want to configure on your device, and the reporter adjusts the one that the device is reporter. Uh, the the device can change reporter, and the backend can change desired. And the backend can react. If you see here, it's clear. You can read and write desired properties and response to change notification, and you can read and respond to change notification on the reporter. This is more or less the same that we did previously with condense in just a single entity here, and we will see a quick example of how we can use the device twin. Uh, there is more about device twin, but in this session, because I try to to keep it very simple. We will just to see that we can create in our backend application some kind of properties, and the device, our simulated device that we did, can read this device app and report it back. So let's go to the demo. If you see here, you have go to devices, home simulated device, and device twin. You see here, we already have a device twin. This is just, you see here already, because we are reporting things, I already have the last update, the fan state, all the data that we reported. This custom, this is just for a previous test that I did. So let's see what we need to do this thing. First, in our backend, our application, let me just clear a little bit here. Oops. Clear here. And clear here. This just clean the space, the things is down there, up there. So let's register for the device, register a connection stream for that, and set some. We will need another class here that is called the register manager. And the register manager is the same connection string as the service that we use to invoke methods, directly invoke methods uh, on the device. Another thing that another advantage that has the device twins. Of course, there's this update of the device twin will depend of your configuration, but if you have this device twin, you can automatically check the status of your devices without connecting with your devices. Your device could be off, for example, it lost the internet connection or some other problem, but you could read the last status of your devices is maintained in the cloud using this. So let's. This is a bit of an ugly method. Okay. So what we are doing here is just we are getting this twin from. This is our ID. This could be a GUI. This could be anything here. It's just an ID, and we are setting. Let's just put it, for example, another different tag. Let's put. Oh, sorry, and again we lost here. Let's go back. Yes, good. Okay. You could put a different kind of tag. I don't know, for example, region, Canada, for example. And we will set that the desired properties I want this as desired, and then we just update the device twin using the device ID, and this is just for printing here. While we just update, we are just making a SQL query or the device twin because it's using a document database in the back, so we can use SQL-like queries in order to query all these kind of device twin and different properties the same way that we use with the relational database. Of course, there is a subset of that, but if you're familiar with SQL, you could use that in these queries that you use here. So, okay, let's try to do this. Changing the demo on hot. Okay, that's one thing first, and then we need to react to this as well, and we need to react as well on the device. Of how we do that? Well, on the device. On the device, we need to get the device twin and update the properties. So in here, we are just creating a device and set a callback if the IoT Hub call me and sending telemetry. And now we are using instead of that, well, as we can do it both. That's what we do here. We just every time that I connect, I will get my twin from the cloud. This will print properties desired to JSON, and then we will set when the backend send me, okay, you need to set these desired properties. I can react that with a callback, and this is the undesired property change. This is the method that we missing. This is the last thing that we are going to see here, and we are just past a little bit of time, but this is just the last bit I have to take. Okay, cool. So this is just a callback, and the twin collection is actually the desired properties that we see here. It's just all this thing here, all the JSON here, that the cloud is that the IoT Hub is telling us. Okay, look, someone update this, and this is the desired properties. React to this. So what we are doing here is okay, we are just making simulation here that we are doing something, but the code here will be react to this and change properties on your device, and then we create a reporter properties because we report back to the cloud. Okay, look, you let me know that this happened. I am reporting this kind of property. This could be more. You can report different things that the desired properties. Desired properties not always is something to change. You can start a configuration here, maybe a different frequency. For example, the frequency of sending telemetry. You can put it like that as well there. So it's saying using always the device client. The only thing that we use in the device is just this device client class, and with this class we do everything. We send telemetry, we send messages, we register a callback in case of the direct method calling, or we get the twin and we set we set all the workflow related to properties to device twin. Sorry. So let's try it out and hope this work. .NET wrong. Okay, if you see here, the first request just give us the properties that get initial properties. Let's see here. Don't know now. Don't know wrong. What? Ah, of course. Sorry. Yes, of course. I forgot to. I forgot to put. I forgot to. We need some variable to do that. I put it here. Uh, Register manager, and that should work. Okay, or backend it. Cool. So if you see here, because we are using the same uh, simulated device, just printed here, and what happened here, he sent an update, and if you see here, we receive that update, and this is the react to the device twin desired property change. That this twin state reported is the message that is called here, twin state reported, and this is only triggered if from the cloud we receive a set desired properties update, and this callback is triggered if that happens. So the only thing that is this is region, but I don't change because I changed on the fly here. Yeah, we can say devices in Canada. Let's stop this and let's run it again. Again, I don't save the file. I just save the file. Device in Canada, simulated device, and so this is just searching for the tags and for different kind. We could do a query based on all the devices that the temperature, for example, is below X, Y, and Z. And that's it. Okay, if we go to we refresh this, we can see here that we're going to update all the tasks, and this is updated and the last version. So that's I think that is all for today. A little bit thing that I have in the end is, well, what we see today is, well, how we can create an IoT hub, how we can create a device in this IoT hub. If we use a real device, or we use a simulated device, or we use an application, we can use the different packages that are available by Microsoft in order to connect to this IoT hub and send message to this IoT hub. We can use the capabilities of the IoT Hub to react to these messages and read it and input it in some places and go back to the device and send data. Yes, actually send data, because when you call uh, uh, a remote method in the device, you are sending data as well. And we see that we can do a little bit more using device twin. That is all the demo that I have for today. A couple of things that I think that it could be helpful for you. If you want to learn more, I can direct you to the documentation of Microsoft that has a lot of documentation regarding to IoT, IoT Hub, device twin, and so on, and all other kind of IoT related services, technologies that Microsoft have available. And as well, I can recommend you the learned. But if you go to this place, let's go back to here. This is the learn. If you go to the documentation, there is a section. There is a learn, and what 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 I recommend of this is because this learn website of Microsoft, if you require create things in Azure and you don't want to create an account and you don't want to put anything of your credit card there, this is a very good place to start because this has a sandbox system that if you pass some of these courses and you need to create some Azure resource, they give you a sandbox. You activate the sandbox, and for 1 hour or 2 hours, I don't remember now the time, you can. They give you a subscription, and you can create all the things that are in the demo or in the course. You can create there testing the amount of time the amount of time that you want inside the limit of the sandbox. But if your sandbox is just run out of time, just create another one. There is a limit, but it's sufficient for learning things from these sites. Another thing is if you are more hardware-like and you are interested in develop embedded software based on .NET, I would recommend two sites, the Wilderness Lab and the Nano Framework. The Wilderness Lab, they do different kind of device, and you can put .NET directly in this. You can search for yourself the kind of devices that they have, and the Nano framework. The Nano framework is from the .NET community, and you can contribute as well. Let's go to the GitHub page. They have a lot of different kind of devices here simulated. Let me see. For example, IoT device. All these devices are supported, and you can, if you are a .NET developer, you can use all this layer to actually program embedded code on the device. And because this is .NET, you could, for example, just install the NuGet from the IoT Hub and communicate with the cloud. Well, I think that for today, that's all that I have to you. If you have any question, comment, or suggestion, or complaint, just let me know. If not, I will leave it right here.